This is TC Daily, the technology show brought to you by TechCentral. If you haven't subscribed to us yet, do so at youtube.com/TechCentral. And while you're at it, why not subscribe to TechCentral's daily newsletter at techcentral.co.za/newsletter. Now, I'm joined in the studio today by Cliff DeWitt, and he is CTO at Netstar. It's good to see you, Cliff. It's been a while. Welcome.
Duncan, thank you very much for having me.
Pleasure. It has been a while. I think the last time I saw you, you were still at Microsoft.
That's right. Yes, we talked about the cloud coming to the continent for the first time. Feels like an age ago, doesn't it?
That's right. Microsoft Azure.
Yeah.
And I was having a look at your LinkedIn profile, preparing for this interview today, and you were at Microsoft for an exceptionally long time. You were there for 16, 17 years, was it?
Yeah, that's right. Yeah, it was a very long time. Saw a lot of change in the company over that time. Very good time. I enjoyed my stint at Microsoft a lot.
When you started, Bill Gates would have been CEO.
He was. Bill was there. I saw the transition to Ballmer and how that kind of worked, or I suppose didn't work in some respects. Got to meet Bill once or twice, which was an interesting experience. Mm-hmm. So, it was a really good time.
Yeah. And then Satya Nadella was CEO by the time you left, I think?
He did, yeah. I got the transition into Satya. And again, interesting to see what a leader who really understands a business can do, right? I think you've seen the sort of trend in large tech companies where sometimes it's run by, say, I guess a more financially or sales-focused guy, and I guess the trend these days is to sort of have more of the engineers run some of these larger organizations. And I think Satya's certainly done very well for Microsoft, focusing on both people and technology. I think that's really what he's done incredibly well.
Yeah, Microsoft certainly is a changed company. At the time you were there, it went from a very Bill Gates dominated leadership style to something that's very different.
Yes.
Much more democratic, I feel, more open culture, etc. So it must have been quite fascinating to have spent a big chunk of your career at an organization that went through such massive change.
Yeah. No, it was. And I think there's a learning in that, right? I think, and maybe it's just the evolution of technology in some respects, right? Because I think when technology starts and it's unique, and certainly there's a unique proposition in the market, in many cases, the inventors or the owners of that estate try to build a walled garden around it, right? I think it's true of sort of, even today, Apple in some respects does that. But many of these tech companies kind of try and defend their customer base and sort of lock them in some respects. And I think Microsoft took that approach initially, if you were in the ecosystem. But I think sometimes visionaries understand that technology gets democratized quickly. And that if you think about opening your technology to different platforms, to different environments, to different demographics, your addressable market goes up exponentially. Yeah. And I think the way Satya approached cloud, for instance, was a really good example of that, where he very quickly realized that if you're going to build a cloud platform, you should support more than just your own operating systems. And I guess likewise for Office as well, where Office was initially only on the Windows platform, but you open it up to a larger addressable market. Not only is it good for the larger ecosystem, but for you as the provider, as I said, your addressable market becomes much, much bigger and does really well for you financially. So I think there's definitely some learning in that.
Yeah. I mean, it's astonishing how Microsoft went from Steve Ballmer talking about the GPL, which was the license behind Linux and much of open source software as a cancer, to Microsoft buying GitHub.
Yes, exactly.
That's quite a move.
It is. And it just shows you sort of, again, I think the power of a leader and a visionary leader, and then also understanding what people ultimately want, right? And I think if you focus on actually providing value and providing products and services that actually work, people will buy them, irrespective of locking them into a platform. And again, I think there's a lot of lessons, even into some of today's incumbents, I think are still falling foul of that. So it's an interesting world right now.
Indeed. So we're not talking Microsoft today. We're going to be talking everything but Microsoft, in fact. So Cliff, you're an electrical engineer. You studied at Wits, but you've always had a knack for computing, a fascination with computing. Yeah. And one of your first roles was, in fact, helping a Nedbank launch internet banking. Tell us about that.
Yeah. So I guess I did a little bit of electronic engineering after I left university. I've always loved electronics. I still sort of tinker with it today, but I was definitely much more of a software guy. Right. So I was kind of drawn to this world of sort of internet. It was kind of 99 to 98, 99. The internet was just becoming a big thing, and I applied for a role, and I got a role at Nedbank. They just sort of launched their first sort of, almost like a proof of concept of internet banking. And the team that I joined left soon after I joined, so I was sort of handed this pet project that was internet banking. It was a fascinating journey because we sort of took this thing into production, into sort of real supported production. And I think I forget the actual numbers, but in a couple of months, it moved from being sort of a trial to the biggest branch in the bank as they were measured, access at the time. So they benchmarked access by how big a branch was. And we sort of just realized, again, the discussion we've just had, if you give people exactly what they want on the right medium and the right platform, how quick adoption happens. And so I lived through that transition of taking it from being an experiment into what was then just a single server, and figuring out how to scale this thing across multiple servers, how to deal with 24/7 because branches obviously closed, so you have support windows. So it was a very different space for the bank at the time, running banking operations 24/7, having to service it, and having to do it at the scale that users and customers demanded. So it was fascinating. Taught me how.
Called NetBank.
It was called NetBank. NetBank. Yeah, that's right. Yeah.
Was Barry Hall the CIO back then?
He was, yes.
So was he ultimately in charge of this project?
He was, yes. And Barry was in my office on the odd occasion asking me what I was actually doing with his bank. I remember that.
I believe he was a tough taskmaster.
He was. It wasn't a fun experience.
But that was a long time ago. So I mean, you must have been building that bank on top of early versions of Internet Explorer, and
we did.
And I don't think Firefox was even out then. It
wasn't.
Netscape Navigator.
It was. Yeah, the browsers were definitely. I mean, we were a Microsoft shop at the time, we definitely supported Internet Explorer. The backend servers were all Windows servers. We used the Microsoft Transaction Server, I think, to build it MTS. So there was some interesting tech in there, SQL Server database.
Right.
But then eventually, we got a little bit more industrial. We had a MQ series server that spoke directly to the mainframe when we got out of the branch environment.
Yeah.
So we made it a bit more industrial over time. And we rewrote it, I think in the first 18 months, 2 years, we completely rewrote it. So we had another project that we rewrote the thing.
Yeah. So NetBank was very much a Microsoft shop back then.
It was. In
fact, Bill Gates came to visit Barry Hall on one or two occasions.
I think it was just before I joined that happened, yes. But it was a big Microsoft shop, and I guess it's sort of how I got introduced to Microsoft. Initially, I was on a bit of a joint development program for the Windows 2000 rollout, and I spent 6 weeks, I think, on campus at Redmond.
Oh, nice.
Yeah, so I kind of got to know the company a little bit, and I realized it would be really interesting to work on the other side of the fence, if it will. So that's kind of, I guess, where I learned the difference between consuming product and being a user of product and the building side of product. And the difference when you build something and sell it to lots of different people versus you use it to run your own business. And I think I then realized that I probably really want to work in a product company. And I suppose it's probably been my journey from then on out.
Okay. So you spent a good 16 or 17 years at Microsoft. Then I kind of lost touch with you, Cliff. So I'm not sure what you did. There were a couple of intervening steps before you joined Netstar. What were those steps?
So I decided, one of my through all my roles at Microsoft, I eventually ended up running what they called the DX, which was sort of the developer division. So sort of everything that has to do with software
developers.
That's it. That's exactly
to quote someone.
Exactly. Was kind of lumped into one division. So I sold Visual Studio and all the sales products. We ran all the big events. But one thing we also did, interesting enough, and with support of Mteto, who was then my boss at the time, we built a very interesting startup program. So we managed to secure some funding from government. We co-opted a bunch of partners together, and we built a fairly successful startup program where we obviously gave startups a bunch of free software, and we worked with local incubators. And I kind of observed this whole startup scene. So on my exit with Microsoft, I and a fellow director who was running the small and medium business, we started our own business in partnership with Metrofile, with a listed JSE entity. And we thought that this whole digital disruption of document management was ripe for disruption. So we built a product to digitalize the document management process. Took us about 18 months to build up a bit of software. And for various reasons, it didn't work. So I guess, one thing I've learned about the startup space is that it's never guaranteed to work. But I think the lessons you learn in starting an entity, working with a listed entity who provided you funding, taught me a hell of a lot about how businesses really work. When it's one thing working in a large corporation where cash flow is not an issue, where you're not really that close to the investor community and understanding expectations. So, yeah, I think we failed at a business level, but certainly at a personal level, taught me one hell of a lot about how businesses actually run and operate. And
What do they say about startups? If you haven't failed at least once, you're not doing it right.
correct. It's nice to say, and it's good to read the books, but when you fail and you personally do it, it's a tough life
traumatic.
lesson. Yeah. It is very traumatic. And that was sort of just before COVID. So I decided that it was time to take a little bit of time off. I took 8 months off. I did a little bit of consulting. I joined a big multinational who was establishing a practice here. They're called Crayon, and I helped them starting to establish a data and AI practice. So we started building. They had a very strong AI competency, so we started building that practice out. And then I was approached to look at the Netstar role, and I thought let's have a discussion. I interviewed, and the board made me an offer. So I was kind of at an interesting crossroads. I was kind of enjoying my consulting role. But as I looked at the company and I kind of looked at sort of where the world was going, both in terms of IoT and data, I really jumped at the opportunity because I think it's a company that has sort of grown over the last 25, 24 odd years. Obviously got a strong brand association with tracking and vehicle recovery. But I think as this world of IoT grows, and we can talk maybe a little bit about how it's matured over the last couple of years, I saw the enormous potential in what Netstar could become, more than just a vehicle tracking company. And so I jumped at the opportunity.
Okay, great. Well, we're going to go into that in quite a bit of detail. There's some pretty exciting stuff to talk about, especially around IoT and AI and machine learning, etc. But before we get to all of that, something I learned about you this morning, in fact, while we were chatting, and I want to touch on that before we get into Netstar, and that's that you have a keen interest in astrophotography.
Crazy hobby.
And we're going to put a picture up on screen now. This image that our viewers are seeing on screen now is the center of the galaxy. Amazing photograph. How did you take it?
Yeah, it's interesting. So I guess I've always had this sort of fascination with astronomy, and it's an interesting intersection of astronomy and photography, which is one of my really deep passions. I've been doing it for sort of 12, 15 years. I've acquired a couple of telescopes, but I've always been really disappointed with my image results. And I guess as with sort of all technology, it's sort of come of age lately. So both in terms of software, but also in terms of hardware. So I just recently bought myself a reasonably good astronomy camera. As with all things, the Chinese have kind of got into the manufacture of cameras. So
the camera is specifically designed for astrophotography?
Absolutely.
So who are the big brands in the space?
So there's sort of two. There's one called QHY and another one called ASI, are the two big guys.
I've never heard of them.
You won't hear of them. The American brand is something called SBIG, Santa Barbara Instrument Group. They're really these weird, it doesn't even look like a camera, right? It's a round block of aluminium. And basically all it is an image sensor with a Peltier cooler bolted to the back of it, because if you can cool the sensor, you reduce the noise on the image. So they cool them to about minus 10 degrees C, minus 15 when you're taking an image, and that reduces a lot of the dark current that comes into the image.
Amazing.
Yeah, it's really interesting. So it really doesn't look like a camera at all. It looks like
these amazing pictures you see of space are not taken on a Nikon or a
not many of
Canon,
them.
no.
So it's certainly not the professional ones. Right. Almost all the amateurs these days are using these sort of dedicated astro cameras.
How much do they cost?
Anything from about $500 to about $2,000, sort of somewhere around there. So
not prohibitive.
Not crazy. I mean, you can go much higher. So
you always can with it.
You can get you get these esoteric brands that do really, really crazy stuff. But I mean, it's not off the charts expensive. So that's what I said. It's kind of becoming acceptable, certainly in rand terms. Slightly acceptable. So and I think the other learning is that you don't really have to have a massive telescope. So the image we saw was really taken with a 135mm camera lens, right? So it's
astonishing. And what sort of exposure are you?
I'm shooting about the most of the good cameras are monochrome cameras. So what you do is you shoot in monochrome, but you have filters that sit in front of it. So you shoot a set of red, greens, and blues if you want natural color. Otherwise, you can use some other interesting filters that look at specifically the nebula emission filters that come off the. So they call them hydrogen alpha, oxygen, and sulfur filters. And the nice thing, if you shoot monochrome,
and you use those in real time with the camera as you
do. So you actually have a clever little device that sits in front of the camera. They call it a camera filter wheel, and it's got a little servo motor in it, and you can automate it all through what they call the capture software. So you can say turn the filter to this position and put it in. And then to answer your question on the exposure, so we're sitting anywhere between 60 seconds and sort of 2-3 minutes.
Okay.
And it's sitting on a tripod that actually tracks the stars. So a large part of the mechanical trick is how do you set this thing up so it tracks the stars.
Otherwise you get a blur.
Yes, because of course the stars are rotating. Yeah. And actually what I have is I have a small little secondary telescope that you, with a very small, almost like a webcam in it, that looks at a star. And then you have another little piece of software that some really smart guys are writing and maintain another open source project. That watches the star, and they lock onto the star, and then they send little correction pulses to the tripod to make sure that it tracks the sky completely accurately. Yeah.
So there are forums online that.
Oh yeah, no, it's another whole massive tribe.
It's a rabbit hole.
if you will. It's crazy.
Right. You're mentioning there's also a whole ton of amazing open source software, not just for tracking the stars and the motion of the Earth. I guess it's not the stars that are moving, it's the planet that's moving.
Yes, exactly.
But also for post-production.
Yeah, it's. I mean, once you sort of get into the world, there's guys that give incredible amounts of their personal time to build these things. And I think as with all good open source projects, there's a lot of contributors as well. So there's both on the planning side. So I guess the three big steps of planning what you want to take a photo of, because the nice thing about the heavens as opposed to terrestrial photography is that stuff stays at the same place. You know where it's going to arrive. As long as there's not clouds in the way, you get kind of what you're going to get. So, so you can plan it out quite nicely. Then there's the acquisition side. So when you're taking the images, you know, how do you control the camera? What filters are you using? How long are your exposures? You can kind of automate that whole thing, and people build these super complex acquisition pieces of software. And then, as you said, sort of there's the post-production side, which is kind of like the Photoshop of astrophotography. So there's a couple of, some of them are free. There's a big open source movement. A couple of them are paid for now as well. So there's some guys that have really spent a ton amount of time there.
So this photo we've been looking at, where did you take this?
So I took it in the Mountain Zebra National Park in the middle of the Karoo.
No light pollution.
Yeah, that's exactly it. So we planned our trip so that we'd be there over New Moon. We were having load shedding as well, which actually in that case is a blessing.
You're one of the few guys who likes the load shedding.
So that was quite fortunate. And I shot for 3 nights. I shot the entire night. So because the Milky Way is such a big thing, the image is actually 42, I think, 40 panel mosaic. So you take lots of individual shots and you glue them all together. And I think the original image is about 0.5 gigapixel. So it took a fair amount of computing power to actually just generate and work with the image. That was a challenge in its own right. Finding a machine with enough RAM and enough compute just to do the basic image manipulation was quite tough, actually.
Yeah. So I guess what we should do is include a link to the full image online.
We can, yes.
With the show notes for this episode, because we can only broadcast in 1920.
Yeah, that's a good
1080 pixels, which does it no justice.
Exactly, it's a great idea.
So anyone who's keen to see it, we'll include the link in the show notes for this episode. But Cliff, you must have been absolutely awe-inspired, gobsmacked, I'm not sure what the right word is, with the images that came from the James Webb Space Telescope that was launched recently.
It's phenomenal, right? It's actually, it's unbelievable. I mean, and in fact, I have as much as I like going to dark sites, it's actually incredible what you can shoot just here in suburban Johannesburg. So I shoot a fair amount just from my balcony at home. When you use the right filters, because if you use what they call narrowband filters, you cut out almost all the light, and you just let the bits through that are specific to the nebula, especially for a mission, what they call an emission nebula. So it's stuff that's transmitting light. It's kind of like a neon tube, right? When the stars are sending out energy and there's this dust and it ionizes and you get this nice glow. So a lot of those photos that you see, the classic sort of astro photos with this dust clouds, all those emission nebula. Anyway, you can shoot those from an urban environment because you just let in just that little bit of light, and then the light pollution doesn't really make that much of a difference.
I would never have guessed that.
Yeah. But anyway, coming back to your question, so I took a shot of a galaxy or a nebula down here. It's called Eta Carini, and so did JWST. And it was fascinating putting the two of them next to each other and just comparing, what you could do with your modest equipment. I mean, you can still see it's the same outline, and maybe we can share that as well. But you're just blown away with the level of detail that's coming off that thing.
Yeah.
I suppose 20 years and countless $1 billion, you expect a bit better than what I can do in my back garden now.
10 billion, I think it was.
Exactly.
Yeah. But amazing images. I love looking at them as well. We've got a few in the office here.
They're phenomenal.
Which I will show you before we go today.
Yeah.
Great. Well, let's get on to your day job, which is CTO of Netstar. So it was quite fortuitous, actually, Cliff, that Altron put out their results this morning. It wasn't planned to have you in here on the same day the interim results were published. You're not the numbers guy, so I'm not going to ask you about the balance sheet and income statement and all the rest of it. But I will pick up on one thing that was mentioned, which caught my attention, and that was a statement that was a change in the sales mix and increased GSM costs to counter the impact of blackouts due to load shedding. What's that about? What's caused that?
Yeah, so I mean, I guess part of our business is obviously tracking. I mean, we're ostensibly an IoT business, right? So mostly known for the IoT devices we put into vehicles, of course. And the backhaul of that tends to mostly be cellular connections. We do run a private network of our own as a backup because bad guys do interesting things with vehicles, so we need a different way of getting off the vehicle. But our primary communication is cellular, and we have noticed, specifically with load shedding, is that as the load shedding happens, the network is not always as stable as it could be. A lot of our discussions, obviously, with the operators, I think we all know that battery theft has gone up dramatically. So when cell towers lose battery connection or lose power for extended periods of time, they go down. And so what we've had to do is increase our GSM costs by allowing for roaming. And so what we do is we make sure that our devices can pair across both MTN, Vodacom, and a little bit on Cell C, mostly MTN and Vodacom in our case at the moment. And so we've had to pair our devices to use both networks, which obviously changes the cost profile for us. We're a large customer of Vodacom, and we use a platform that they call GDSP, which is the IoT network provider. So it's actually part of the Vodafone group. So that's our primary communication mechanism. But yeah, that's I guess the sort of the backstory behind that. Just because of the load shedding causes a bit of network instability and tends to be transient. Like I think we've all seen it, right? I think we've all seen driving around, all of a sudden you lose connectivity on your phone. Our devices are the same, and of course because we have such a big addressable base of devices out there, north of 1 million devices in the field, we have a pretty good picture on sort of where things are not connecting.
I always assumed, obviously I have a tracking system in my car. I actually don't know which company it is, to be honest, but I have one in my car. And I just assumed it was running on GPS or some sort of satellite-based technology. I'm interested to hear how dependent you are on GSM as well.
Yes. So it's quite an interesting sort of, if you break the device in the vehicle down, sort of what's happening. They're actually fairly complicated devices. So yes, it definitely speaks to the GPS, but the GPS is obviously receive only. So what you're using the GPS for is to figure out where you are on the planet.
Right.
So that gives you positional data. It gives you very accurate time data. So GPSs are really good for two things, giving you position and giving you very accurate time. In our case, what we also do is we take input from, like I said, sort of our own terrestrial network that we still run and operate. So we're able to communicate both ways with our devices on the terrestrial network. But the backhaul, so the actual transmission out of the device, is largely cellular based.
Okay.
And I guess that's the sort of where has in large ways defined where IoT is today. Is that if I have a device, ignore for the fact that it's in a car. I have a device, it has some sensors on. Those sensors could be GPS, it could be positional, but it could also be things like, in our case, we have accelerometer sensors on the vehicle as well to try and tell it's change in acceleration. We can also tell how you're driving, so that's always interesting. Is that if you're swerving quite quickly, we get lateral accelerometer data. If you brake very very rapidly, we can see the deceleration. Obviously, we try and figure out if you've been in an accident as well. Maybe we can talk a little bit about that. So, I guess the intent with sort of what I'm trying to explain is that IoT is sort of this culmination of having a device out there, a small device with sensors on it, whatever those sensors happen to be, and then transmitting that information back to some type of cloud. And in our world, we're mostly resident in Microsoft's Azure's clouds, so we transmit that data, and you need a connectivity stack to get back. And that's why cellular is so important in that. And it's interesting because the networks themselves, and I know you talk a lot about what's happening in the network space and the telco space. I think what's happened is the evolution of that up until now has sort of been, well, cell phones came up, 2G came up sort of 25 years ago. People realized that all of a sudden you now had a network capability that wasn't tied to your Wi-Fi in your house, all right? And so when tracking systems originally started, some of them actually literally took cell phones took them out of their cases and bolted them into a vehicle and transmitted their GPS data over a cell phone, right? And the industry grew, and now you get a GSM device in a module that size. They're made in China. You can buy them 10 to a dozen. They cost a couple of dollars each. So the connectivity has become ridiculous. But what's happening is that the network providers have now finally realized that there's a space for IoT devices, because in some ways there's two classes of devices. There's you and I who want to watch YouTube in 1080p on our phones, who actually care a lot about connectivity, but also the bandwidth behind that connectivity. But the other class of devices, ostensibly the IoT device, that really doesn't really need high volume, high bandwidth connectivity. It just needs good coverage in a large area. And so there's sort of two standards that are evolving now. I'm sure you've heard talk about Sigfox, was originally SquidNet in South Africa. That's ostensibly a network that has stood up to provide IoT connectivity.
That network's just been rescued. Was Netstar one of the participants in that?
We were originally. We weren't financially in it, but we did build some devices that supported the network, and we still have them. So we do believe there is a future there. And I'll explain why now. But what's also happening is, the mobile operators are not going to get left behind. They realize how big what they call machine-to-machine or IoT is. And so there's a GSM standard that's evolving that's called NB-IoT, narrowband IoT, that is specifically engineered in the GSM spectrum to be, because what you want in this world is high contingency or high collective connectivity, but less bandwidth. So if you connect on a standard cellular network, basically every one of your connections becomes something like a phone. In this world, what you want is a very narrow band, and hence the narrow band term in there. So it means you can have lots of devices connected to the network, not eating a ton of spectrum, because they don't need 5G YouTube type quality. They just need to send a data stream out. And so NB-IoT sort of is the direct compete in some respects to that. And then there's the LoRa standard, which is sort of LoRa is a bit more of a toolbox, right? It's more of a, here's the technology stack, and people can stand up their own networks using LoRa technology to connect to the backend. Anyway, the long and short of it is that you need to get the data off the device and into the cloud. And those are sort of the three choices you have at the moment right now. And I think, I suspect what's going to happen is we're going to have probably a sum of Sigfox and NB-IoT kind of dominating the space in a while. And it'll be good to have some optionality.
Right. Which technology makes more sense for a company like Netstar?
Yeah, so we, as I said, we did engineer some products around Sigfox. When the SquidNet sort of startup, well, it was a largely funded startup, sort of had some issues. We changed direction a little bit. So we now sort of have a dual strategy. We'll look at both Sigfox, but we're heavily invested in going down the NB-IoT route as well. And I guess the mobile operators have enough funding, enough capital to build large NB-IoT networks. I think from their perspective, they're obviously looking at the demand side. My understanding is that most of the LTE base stations support NB-IoT, and they really it's a software switch to turn it on. And I know for a fact that Vodacom has pretty good coverage now, actually nationally. So I think we'll see it entering the market pretty quickly now.
So take us through, give me an idea of the size of the Netstar ecosystem network. How many devices, endpoints do you have out there that are feeding data back all the time? How many of those are cellular connected? How many of them are connected to an IoT network?
Right. Yeah, I mean, it's an interesting company. We sort of have anywhere north of 1 million devices, actually sort of 1.2, somewhere around there, growing all the time. Those devices, most of them are cellular connected. Again, we have a secondary channel through our RF network to speak to them. We ship anywhere north of sort of 300 million messages a day off those devices into our backend. We concentrate all that backend data into our cloud infrastructure.
These are small packets of data that are coming.
Yes, very small messages. They can be bigger. So if a vehicle's been in an accident, for instance, then we stream quite high resolution data on accelerometer and GPS. We take people's safety very seriously. So then we try and figure out quite accurately whether you've been in an accident or not. So the packets can grow. We also have a fairly big camera network. So what we're also doing is building up a fleet of cameras. So for instance, every single Patco bus in South Africa or in Gauteng, in our area, has a set of Netstar cameras on board. And those cameras are becoming a lot more capable. And so you can imagine their data bandwidth gets big quickly, right? Because we're looking at both, road-facing video. We're looking at in-cab and passenger safety video. We also have some pretty clever AI-based cameras now that we're using to determine driver behavior, both in terms of concentration on following the road, but there's also really nice AI models that predict driver fatigue and distracted driving. So all of that video is coming into our back-end systems as well. And
is that all happening in real time, or does the video get synced at a certain time of the day?
Yeah, it's an interesting question. So we've had to deal with that problem. So we have the ability to send some snapshot data in real time, so that they are all connected. But then what we also do is we have in-cab storage of that video, and then in depot scenarios, we offload bulk that video where we have a better link. So that we don't all send everything over the cellular network, where we have a dedicated Wi-Fi network.
And is it all being analyzed by computers, or do you take chunks of it and look at it as a human being, have a look at the video, and how is it processed in the back end?
Great question. I guess we're sort of stumbling into this whole big data type scenario, but I guess that's sort of the evolution of IoT in some respects, right? Is that IoT, is this creator of large amounts of data, and I think the world is starting to deal with that problem, right? Where up until a couple of years ago, it was how do I get the data, right? How do I connect it? That was the challenge of the time. Is the collecting of the data and shipping it. But as we've sort of discussed, the networks are becoming much more capable. Connectivity, there is optionality now. So now I think the world is moving away from, we're pretty comfortable collecting large amounts of data, whether it's video or telematics or temperature sensors or whatever the case may be. We've got this all on the cloud now, so now how do we deal with this amount of data? And camera is such a good example, right? So, with all of our hundreds of buses that we manage, you start dealing with some real practical problems, like, are all the cameras on the buses working? So we're starting to more and more deploy AI to look at our data estate and to try and reason over our data estate. So we do use employees and humans to help us look at the data. But our point of view is that we would like to make that we don't want to use humans for the really menial tasks, right? We want humans to work on the value additive tasks. So for instance, our AI models now are reasoning over that camera data and trying to determine whether at least the cameras are in a working state. Because when you have hundreds and hundreds of cameras out there, you want to make sure that at least on a specific bus, you have an operating set of cameras. So we're looking at that data to determine, are the cameras pointing in the right direction? Are they dirty? Are they blurred? And so we've built some pretty smart custom models to figure out, what the data estate looks like. And then we're doing the same thing sort of on our telematics data. So one thing that's really important for us is determine whether a vehicle has been in an accident. And so we are using AI quite extensively on our telematics data to look at the crash analytics that comes with the vehicle. So our devices have, as I said, have accelerometers, and they look at the GPS data, and so a device will say, I think I've been in an accident. But we have limited processing capability on the edge. It's something that we can talk about, but later maybe it's how sort of the edge is becoming more capable. But today, certainly that's the truth. So we ship that data to our server, and then we have a very complex multi-year project that we've worked on to refine that data to determine whether it's really been in an accident, so that we can build up a model to determine whether it's been an accident. Then I can say, Duncan's been in an accident, and I can tell his insurer or tell his healthcare provider that we think you've been in an accident. And of course, their accuracy is important. Right? I can't be telling you every 5 minutes you've been in an accident when you haven't. You get into the cry wolf scenario. So I think that's sort of how the world is evolving, right? Where we got comfortable storing data, collecting data, but now the challenge is analyzing the data and gaining insight and meaning out of the data.
Yeah, fascinating. I mean, a lot of the data that you're getting in and the patterns that you're able to determine from that data must be very similar across many instances. I mean, you could probably tell if a vehicle has been stolen based on driving behavior has suddenly changed, or it's going into an area that's where the driver doesn't normally go.
Yes.
That sort of thing.
Absolutely.
You're able to determine all of that. I mean, if a vehicle gets stolen, could Netstar potentially say, the owner might not be near the vehicle at the time, it gets stolen from a shopping center? Could you actually potentially proactively say, we think this vehicle has been stolen, let's contact the owner? Yes,
so we actually absolutely do that. So today, we have a feature we call early warning. So our early warning customers, we give them a little key fob to put on their keys. Right. And that's a nice leading indicator, because if we see the vehicle move without that key fob being present, we know automatically that something nefarious is happening. Of course, the bad guys do interesting stuff. So Sometimes they try and block signals, and et cetera, et cetera. But we know with a fairly high degree of accuracy that especially if you're on our early warning feature, that you've moved. I think we also do, especially more so less so in the consumer side, but certainly as you sort of get through our more mature tiers. So in our fleet operation environments, our small and medium businesses, and of course in our large fleet businesses, you start getting to scenarios, and you can actually do it. You can actually do it with a product that we have today. So your example of going to areas that you shouldn't. Mm-hmm. So if you're a customer of ours, we have a really cool app. It's called My Netstar. You should go check it out if you don't use it. And you can draw geozones around areas that you want notification on. Mm. So you can today in our consumer app, you can say, if my vehicle ever goes there, please send me a notification. And we'll do that if your vehicle ever goes there. So you kind of now start being, it's exactly the point you were making, right? You start becoming a little more in control of your data. And I guess that's also the other sort of where IoT is going, is that we can provide you a point of view, but what's also nice is we provide you a set of tooling, because your behavior might be slightly different from the next person's behavior. So your idea of a geozone maybe not be somebody else's idea of a geozone. So certainly we can do that. But I think sort of where you were alluding to is getting really interesting, and I suppose it comes back to that AI discussion, right? And maybe it's just where the industry is right now and where compute is. And I think cloud has been a large provider of that, is that I guess the holy grail of a lot of the stuff is that you start getting an individual-based model based on Duncan's behavior, right? And I think the insurers have gone there, well, not all of them, but some of them have gone there with, let's call it UBI and driver behavior. So sort of what Discovery started, but the whole advent of what we call UBI or user-based insurance is sort of gaining momentum globally now. But I guess the trend there is individual-based models, whether it's to affect your insurance premium or to determine your driver behavior. Mm-hmm. And I guess we're at a point, this is why I made the point at the beginning, is we're at a point in the industry where we have enough compute to reason over all of that data that we have and then build an individual model for Duncan. Mm-hmm. Where I can say, well, this is Duncan's typical driving behavior, and almost fingerprint you and say that if we see Duncan driving differently, provide an alert. Mm-hmm. Up until now, it's been the model to do it has been known, right? But the compute to do it has been really prohibitive, right? When you've got 1.2 million customers and 1.2 million devices, to reason over 1.2 million models becomes quite tough, right? Mm. But we're at that point finally where there is enough compute in the cloud to be able to do that practically, and practically means financially practically as well, and to provide a service that is valuable that hopefully you can monetize. So I think we're going to see a lot more of that individual-based experience, reasoning over your data without you having to hard code the parameters, but where the model can provide you insight from what it's learned. And I think that area is ripe for explosion right now.
Fascinating. So I wanted to just switch tack a little bit, because I want to talk a bit about what Netstar is doing in the autonomous driving space, particularly industrial applications. And I think mining, you've got some actual examples of some projects that you've deployed.
Yes.
So you've got technology that is preventing vehicles in industrial scenarios having accidents with each other and knocking people over, and that sort of thing. Tell us a bit about what you're doing there.
Yeah, so in mining specifically, there's some governance and some legislation around these very heavy, the large yellow metal, but even the bigger ones, right? These large trucks on some of these open cast mines specifically.
They're huge,
They are massive, right? And if you think about driving that thing, the driver's on a little box at the front.
Yes.
He has no idea what's happening around him. So he has a point of view that's here, and he can see sort of in front of him, but he can't always see on the sides or around him. So the legislation is about, they call it collision avoidance. And what we've done is we've had a very complex project, a multi-year engineering and software project that we've delivered that does what we call collision avoidance detection and prevention. And basically, we put these devices on each of those big vehicles, and it's not just GPS data. So there's time in flight calculations. So these things actually speak to each other in real time. So it's not going back up to the satellite and coming back down on the server. It's actually happening in real time in the environment. And they do these pretty complex calculations of where that device is, and there's multiple transmission points along these large vehicles to figure out, are these things actually going to potentially impact each other? We then provide the driver in the cab with some audible and visual feedback, And if the vehicle supports it, we've done some work with some of the universities, we can actually plug into the autonomous system and, for instance, brake the vehicle and bring it to a halt if need be. Mm-hmm. And so it's a really nice example, I think, of where sort of traditional telematics is going. So we're definitely not we're not claiming to be Tesla and driving the vehicle, but I think this is pretty serious stuff in terms of riding over pedestrians, and we put it down onto the people level, onto the smaller vehicles that are driving around there, because one of these big trucks may not see a bucky down here and literally just ride over it, right? So it's a really great solution. We've deploying it quite successfully over multiple months here and up into Africa, and our customers are really happy with it. So it's really exciting to see what you can do, kind of dealing with helping save people's lives ostensibly, and really it does in some scenarios, and using local technology and innovation to do that. So
yeah, it's interesting what you say about you not being Tesla, but I mean, are there potential applications for taking this out of an industrial environment and using it in a car?
Yeah, I mean, look, we think about that all the time, right? We're definitely thinking about how do we take our telematics devices and use them in a larger environment. We obviously talk a lot to the local OEMs in the market and what they're doing in terms of telematics. I think collision avoidance in high velocity scenarios gets a lot more interesting. I think there you're probably dealing a lot more with video analytics than you are with telematics data. 5G probably is a leading indicator of that. I think a lot of what 5G promises somewhere down the road, excuse the pun, is that inter-vehicle communication.
Yeah.
So we're certainly keeping an eye on that and seeing what role we play in that, because I think that's when it does all come together, right? Because today, if you just look at our example on the mine, right, the reason it works is because we have a solution that speaks between the vehicles. So if you understand what each other are doing, you can build models to prevent or reinforce the scenario that you want to. I think today, the challenge mostly is that most vehicles operate independently of each other, right? And if you think about your driving today, it's you, the human, who's looking at the other vehicles around you and making decisions on how you behave in that scenario. But I think once we get to the nirvana of having inter-vehicle connectivity, then I think the world changes very rapidly, right? Because then your vehicle knows that a car 10 cars ahead or 20 cars ahead has just braked rapidly. You can't even see it yet, but it starts preparing for that or even avoiding the scenario. That's, I think, the world we're moving to quite quickly.
Yeah. I just hope there's enough electricity for these 5G
yeah, that's a different discussion. Infrastructure is a given, I suppose.
Before I let you go, Cliff, I know you're passionate about education and skills development, etc. You're doing a heck of a lot of interesting stuff at Netstar, ML, AI, etc. It requires some pretty advanced skills. Are we producing enough of those skills here in South Africa? Can you get the talent at Netstar that you need? What are your views around that, and what the universities perhaps should be doing to prepare youngsters for this new world of work?
Yeah. I mean, it is a massive passion of mine. I think something that I got quite deeply involved in when I was at Microsoft. I did run the developer education business. And I still remain quite deeply entrenched in it. So I'm on a board of a local school. I did Grayson Prep in Sandton. I still sit on their board. I'm on 2 advisory boards at WITS still. And I guess the reason I do that is that I really think sort of South Africa's at this inflection point of, I think there's a lot of talk about 4th Industrial Revolution, and we all understand that the world is fundamentally changing, right, in terms of, I think there'll always be a place for resources and economies that can produce raw materials, and I think we'll participate well in that. And we've just shown over the last couple of years how well our resource market has done and largely supported the country in its current Exactly. Let's call it what it is, right? Yeah. But I think we should not shy away from the fact that the knowledge economy globally is growing at an astronomical rate. And I think we're at this point where we must decide whether we want to participate in that, right? And participation can mean 2 things. It can mean participation in terms of consumption of what some of the other markets on the world are doing, or participation could mean, are we an active participant in producing, building, engineering solutions in this 4th industrial world? And there, I think the key ingredients, are education, capacity to play in that world, globalization in terms of how do we not compete globally, but also how do we collaborate globally, and hence my some of my involvement at WITS. I think we still sit on really globally competitive R&D, thinking. I think we solve problems in a very unique way. But I think it's also incumbent on us to make sure that our literacy, our maths literacy, our engineering literacy, our ability to produce engineers, scientists, biologists at that right level are essential if we're going to participate in this world, right? Because this technology is really coming together at the moment to solve some of the most complex problems there are on the earth today. And I think it's really important for us to think carefully about the skills we produce to play in that market.
And it starts at the basic education level, where I guess there is a worrying lack of capacity in terms of teaching resources around maths and science.
Yeah, I mean, there is. And again, I think, and I don't only want to make it government's problem, because I don't think it is, right? And I think that's personally why I give a fair amount of my own time towards it. A good friend and a mentor of mine, ex-Microsoft GM Zohib Hussain, sits on the maths board. You look at the amazing work that organization does to help with teacher maths literacy. I think it's incumbent on lots of us who are passionate about this to help be the change and not just sit on the fence and criticize it, right? Because I think that's the way the problem really gets solved, is when people roll up their sleeves, dig in and get it done, right? So, yeah, there's definitely challenges, there's no doubt. But, I'm always encouraged with when you sort of get in the trenches, you see the potential. I think it gives everybody so much passion for what could be, right? So I think if everybody plays their part, I definitely think we can participate in a meaningful way, right? But yeah, let's not shy away from the fact that we do have some work to do, right? Both at the primary level, the tertiary level, and I think if everybody gets involved, we can solve this problem.
On that positive note, I think we could carry on talking all day, Cliff, but we need to draw the line on the conversation somewhere. On that positive note, thank you so much for sharing your fascinating insights with TechCentral and for joining us in the studio today. Cliff de Wit is CTO at Netstar.
Thank you, Duncan. Thank you for having me.